My name's Alon Gavra. I've been with AppsFlyer for the past 3 years. The first two I spent as a backend engineer working on the main business logic of the company. So I have a lot of hands-on experience in the production system. A year ago, I transitioned to lead one of our...
Can you speak closer to the microphone?
Sure. So a year ago, I transitioned to lead one of our platform teams, the real-time infra team, that its first and foremost responsibility is dealing with Kafka. And the idea was to revisit how we did our Kafka infrastructure and architecture and see how we can modernize it and support our next stage of growth. One thing you should know about me is that I always try to find loopholes in everything I can. That basically means that I read the documentation from the beginning to the end, but it also means that I got banned from several game nights over the years because of this. All right, so for the next 30 to 40 minutes, we're going to discuss how we modernized our Kafka architecture at AppsFlyer, some of the challenges we encountered while doing so. We're going to have some quick wins for whoever's running Kafka in production. And let's try and have some fun while we're doing it. So AppsFlyer in a nutshell, it's basically this. AppsFlyer is a mobile application measurement and analytics platform. What it really means is that we help app marketeers measure and optimize their user acquisition funnel. So we get a lot of data incoming, and we have to be pretty quick about telling our clients if their ad campaigns are worthwhile or not. So whenever you click on a mobile ad or whenever you do a meaningful event on your phone, those events are sent to our platform, and we have to ingest them and do our magic and provide value for our clients pretty quick. That's enough marketing material for now, I guess. All right. So, what does all this data translate into? We deal with about 1 million incoming HTTP requests a second. All those requests will be translated into Kafka messages and will be passed around and duplicated and enriched in our system around 4 times, depending on the flow they go into. We do all of this on 20 Kafka clusters on 400 AWS instances. We're solely on Amazon infrastructure. So that translates to about 80 billion events daily. It's seasonal, but that's the ballpark. This next graph is actually not mine. It's one of our CEO's favorite graphs. He likes to say all our graphs look like hockey sticks, the revenue, the amount of new engineers, the amount of new deals, but he keeps forgetting to talk about the amount of traffic. So now we process around 80 billion events a day. A year ago, it was 50 billion. 3 years ago when I joined, it was 8 billion. So what this graph really represents is that R&D is always playing catch-up with business in AppsFlyer. We're constantly evolving our architecture to support the next growth spurt. And we really like to say that we always try to find the best solution for the problem. So over the years, we've changed a lot of technologies. We've changed our databases. We even changed our primary programming language. But the one true constant over the years has been Kafka. Around last year, we really saw that what we were doing was unsustainable and we needed to spice things up. So how do we do all this magic? This is a very simplistic overview of AppsFlyer architecture. You can see that Kafka sits right in the middle, basically. What we have here is on top, all your mobile phones keep sending us a lot of data. Don't worry, it's GDPR compliant. And we have our web handlers sitting behind AWS's ELBs. And these web handlers, their sole purpose in life is to dump all that data into Kafka for future processing and enrichment. Some of those web handlers do some basic logic of redirections, but that's not really interesting. So the data gets into Kafka, and then depending on where it goes, on its value, it goes to certain flows. But basically, you can see that our attribution engine, the main business logic, feeds off of Kafka. It used to sit on RabbitMQ, but we switched it to Kafka when we felt that Kafka was could guarantee the low latencies that we needed in this flow. Our dashboard, powered by ClickHouse and Druid, providing SLA of 1 minute freshness of data, also feeds off of Kafka. We have the push API and postbacks. Those are basically real-time affirmations to our clients about how their campaigns are working. So some of our more savvy clients have programmatic logic on these postbacks, and there's a lot of money involved, so we can't really afford any downtime. And we have a main consumer that reads all the data and pushes it to S3 for future reports and backup. So there's a good quote about Kafka that goes something like, if your production system is a body, then Kafka is the circulatory system. And the data is the blood being pushed around to various organs. And you can see that in AppsFlyer, that's certainly true. All right. So this is how we started. Meet our monolithic Kafka clusters. When AppsFlyer started around 8 years ago, it was really, we started with several Kafka clusters, and we had Kafka clusters of replication factor 2 and replication factor 3. And if the data was important, it's set on replication factor 3. And if it wasn't, like logs or something that we could afford to lose, it's set on replication factor 2. And so topics were placed on clusters by their business value. And this is actually a really good way to start. If you're a small-sized startup, it makes a lot of sense. The important stuff is on replication factor 3, and the rest is on 2. But at a certain size, when your R&D organization grows enough and you have a lot of teams interacting, you can't really have everybody be on 2 or 3 Kafka clusters. And this is because if you have a broker failure, it affects multiple flows. If one of your R&D teams has a bad deployment and it drinks all the resources, it affects all the other flows. So it got to be really, really noisy, and this is the problem that we actually attempted to solve. All right. So first, some good news. Kafka is a really great tool. It works really well right off the bat. The standard configuration of consumers and producers and the brokers actually, they offer great performance for most use cases, and it's really easy to just coast along with these factory tunings into your production, and everything will work fine. But of course, it can always work a little better. This graph is one of my first quick wins. This shows the CPU usage of one of our Kafka clusters brokers. And you can see that around 8:30 we deployed something, and CPU usage dropped dramatically. And what we did here was actually change one of the main producers to these clusters two settings. One is the batch size and one is the linger MS. And if you're not familiar with those, then batch size is the amount of data that we allow the producer to send to the brokers. And linger MS is the amount of time we allow the producer to accumulate this data and send it to the broker. So what happened here is that we enlarged these from the factory settings to values that made sense for us. Basically, we stopped producing every 2-3 records, and we started producing in batches of 15 to 20 records. And the impact is amazing. You can see that we really elongated the life of this particular Kafka cluster. It had the side effect of if you're compressing your data, then bigger batches, they compress better. So we actually saved a lot on disk space as well. This next slide really sums it up. If you take one photo of any of my slides today, this is it. And it's actually not my slide, it's Netflix's slide. We did these tests as well, and we got very similar results, but they did it first, so kudos to them. It's a really interesting blog that this piece is taken from. So it really shows the effect of playing with these two simple parameters. And Kafka has around 300, 400 more parameters you can play with, so imagine the possibilities. All right, so who here does on-call shifts at their work? Raise your hands, please. All right, so about half the room. For the rest of you, you're all very, very lucky. But for those that do on-call shifts, at AppsFlyer, we also believe in taking responsibility for your services. All our R&D teams participate in this on-call culture. We believe it makes our developers better, helps us write more robust services, but it also led to the evolution of sleep-driven design. And few people are laughing, great. So what do we need to be able to sleep better at night and reduce the amount of pagers and on-call incidents that we have? We need 3 simple things that we abide by, and that's improved infrastructure, great visibility, and great tooling and automation. And this should result in less pagers. We'll see later if it worked. Spoiler, it did. All right, so let's dive into it. Improved infrastructure. Anybody here knows who this guy is? Yeah, so the Indian guys know who this is. This is Rohit Sharma, right? Said it right? Yeah, so in Israel, cricket isn't really popular. But the reason that I know Rohit, and I'm a big fan of him, is for those who don't know, Rohit Sharma is the captain of the Indian national cricket team. He's very popular in India. And a year and a half ago, we signed one of the biggest mobile sports streaming apps in India, Hotstar. And whenever the national Indian cricket team plays, we'd see huge traffic spikes in our system. It really put a lot of stress in our system because about 500 million Indians would sit and refresh on their mobile phones to see the scores. Yeah, you can see that people kept talking about cricket games and getting ready for them for a couple of months because we were really underprepared to face this traffic surge. The first time it happened, everybody was like, what's going on? Are we being DDoSed? We weren't. So yeah, for a couple of months we had this big cricket obsession. The last message there, remember the date, November 11th. Because I got the team a little bit before September, and I knew we had to make a lot of changes to survive the next upcoming months because we had the Asia Cup of cricket coming up, and then we had 11/11, the AliExpress sale coming up, and then I think it was Cyber Monday, no, Black Friday, and then Cyber Monday, and then Christmas. So a lot of traffic surges coming our way and accumulating and putting stress on our system. So in numbers, that's 20 to 30% for each event, and for Christmas, it's really all over the system because we have a lot of e-commerce applications. Then on top of those 30% for Christmas, you have 30% spikes for cricket and AliExpress sales. So stressful times. So we took the opportunity to do a lot of infrastructure work beforehand, and that resulted in around 200% increase in our Kafka brokers. And the reason is because we were already pretty under-provisioned before all of this, and also because of the architecture that we chose. So let's look at that. So, monolith, nice to see you. Hope we never see you again. Let's see what happened. Yeah? All right. So, this is what we did. We broke up the monolith. We chose the producer-owner cluster model. That basically means that the teams that are producing data to the clusters are in charge of the clusters. We chose to separate to a lot of mini clusters that each hold a flow that we can encapsulate on that cluster. And this really solves the first problem we had of isolation in the system. Bad deployment, no problem. It only affects one cluster, one flow. Broker failure only affects one flow. So this makes a lot of sense. And there's another great quote about how your production system ends up looking like your R&D organization. And this is certainly true in our case. Each team can have multiple clusters, and the architecture suddenly really looks like the R&D organization chart flow. So production imitates life, I guess. Great. Another choice that we made at this point was to run at around 60% capacity. Where did we get this number? Well, Google recommends 50% for your production systems that are open to the world, where your traffic isn't really controlled by you, but by your clients. But 50% is really expensive, 60 is less expensive, so we ended up with 60. And a good place to be is really at 50 to 70%. And if you're running your production workloads at 80%, then a broker failure can really cause a cascading failure like dominoes, because the effect it has on other brokers when one is down is much more, it's felt much more than if you're running at 60%. And it's really easy to see when you're approaching 70 and you need to resize. So it gives you a lot of place to breathe. Yeah. What else did I want to say here? Okay. So last thing about this slide. This is really a change in how we think about production now. Because if we'll go back here, anybody remembers ESBs, Enterprise Service Buses? A few of the older guys here? Yeah. So somebody told me that if we wait long enough and all software patterns reemerge, everybody thinks suddenly that they made up the great new thing. So basically with the old architecture, we recreated the Enterprise Service Bus, right? We had this cluster serving as the pipeline. Everything, all our services were communicating through it. It became a single point of failure. So it reemerged 20 years later. So the advantage here is the change in thought basically is that Kafka is no longer the whole pipeline, right? It doesn't encompass the whole production system. Not all your services are on a single Kafka cluster or several large ones. Now, the mini clusters are part of the pipeline. They're really easy to change, they're really easy to upgrade, to orchestrate Kafka moves. They become part of the pipeline, and it's a really interesting change in thought. It's what really enables us to start thinking about Kafka cluster autoscale. That's a dream of mine that I hope will reach soon. So this has had a lot of interesting changes on our organization, and so far it's been working pretty good. So we achieved infrastructure as a service. And what does this really mean? Well, A lot of people say software as a service or platform as a service. And at a certain point, for those of us who are closer to the DevOps side of things, developers really don't like platform changes. You have to keep it as simple as possible. So this really helped because you can roll out your changes on a single cluster and not have everybody involved. And the motto at AppsFlyer is the developers can know what's going on underneath the hood, but they don't really have to. So yeah. All right. Greater visibility. So can anybody tell me what's wrong here? Don't feel bad. It took me like a couple weeks to find it, to notice it. Well, you can see that in the legend we're missing several Kafka brokers, 5, 6, 7, 9, 12, 13. This is actually a 60-node cluster, and we're only seeing metrics from half of it. Yeah, but you can't. It's really difficult to notice things that you don't see, right? So in the old version that we were running, we had our metrics plugin coupled with the Kafka server, and it crashed. And the only way to revive it was to restart the Kafka server. And if you're running Kafka, you know that's a bad idea. So we had to decouple it, and basically we started pulling all the data from JMX and shipping it through Telegraph to our Graphite stack. And suddenly we had a lot more visibility around everything. We currently have about 15 megabytes of Kafka-related metrics in the system. So that translates into a lot of dashboards. And when you're waking up at 3 a.m. to deal with a Kafka-related production issue, you want your key metrics to be in one place. And this is our landing page, where you can see the amount of bytes incoming, the amount of messages, log flash stats, which is how often we write to disk, the load average, CPU usage, disk space, request handler average idle percent, which is how idle is the broker to receive more incoming traffic, leader changes, and under-replicated partitions. And all of these are metrics that we have alerts and pagers on now. We used to only monitor under-replicated partitions and disk space. But by the time you see those, then it's already too late, I guess. And this is like selected metrics that I recommend that everybody check whenever they're whenever they're running Kafka. We have around 5 or 6 other Grafana dashboards full of metrics that whenever we have something that's unexplainable, we go and search them. But these are the key metrics that we use. And this slide is actually pretty interesting because I don't know if you can see it, but on the 22nd, early morning, the amount of data, the bytes in, jumped in to be twice as much what it used to be 24 hours before. And I got a call 8 in the morning on Friday from one of our R&D teams saying, Alon, something's wrong with Kafka. I was like, okay, what's wrong? It's like, I have a problem with one of our servers. There's a lot of Kafka lags. I don't understand why. And I can see that the behavior changed. There's a lot of less available resources. So I opened this dashboard and I looked at it and I said to him, yeah, everything looks fine. Like we're holding, there's no special errors. But I see that the amount of data jumped to be twice as much as it was. What happened? And then he came to the realization that the service that was publishing to Kafka, they were putting the configuration for a downstream service on the Kafka messages. And one of our clients changed his configuration and integrations and message size doubled. So that leads me to the next point. Broker metrics are nice, but to have a holistic view of your system, you really need client metrics as well. You need to be able to look at your consumer and producer and how they're working and interacting with your broker. And I used that production incident to force that team to move to our new Kafka library that had metrics for the producer and consumer. We standardized it, and now everything is much easier, and we have, and now they could have solved it without calling me and waking me up because it was 8 in the morning on a Friday. So yeah, use production issues to push your views on how production systems should be run, and that's it. Yeah. All right. So in Grafana we trust. Now that we have all our metrics. So yeah, all those metrics, though, the key ones should be alerted on early enough that it's actionable and it's not everything's on fire. So remember that. Cool. So tooling and automation. When I did this presentation back home, I didn't have this slide because Terraform and Safe, I'm so accustomed to them that I didn't really think I should mention them. We do all our provisioning with Terraform. We do all our Kafka installations via Chef. Terraform is a great tool if you don't know it. If you do, great. We can provision clusters in under 5 minutes. The next phase is hooking it up to Jenkins or GitLab CI and having developers fill in a little form. How many brokers do you need? How much traffic are you going to handle? What version? And then having them provision clusters on their own. Yeah. So when you have 400 instances in production of Kafka and you want to do a rolling restart and remove the bad metrics plugin that you have and start using a new one, you don't want to do it manually. So this is a great tool by Yelp. They have several utils there, but the best one, in my opinion, is the rolling restart tool. It allows you to basically do a rolling restart and do a pre and post command of the of stopping and restarting your Kafka, and easily do upgrades. Check it out. If anybody here works at Yelp or knows people at Yelp, come talk to me later. We have an open merge request to them for 2 or 3 months now about authorization in this tool. Yeah. We started using Kafka Manager. It's a great tool for managing Kafka. It basically it hooks up to JMX and it gives a lot of metadata. Our developers love it because it has a nice UI and they can see their Kafka legs and how things are interacting without having to use the CLI, which I'll never give up. But yeah, it's a great tool. It offers great visibility. Developers really love it, and yeah, that's enough, I guess. All right. When you're running so many Kafka clusters and you have hundreds of topics, you need some more supportive tools. So we wrote our Kafka Gate API, and this is an in-house middleware written with Go, of course. It does a lot of things, but the most important thing that it does, in my opinion, is a topic locator. You just type in the topic's name and it tells you, oh yeah, it's on this cluster, this is the metadata, because it's easy to lose track with so many topics. And then you can listen in on a topic and open our local consumer and see that the topic is behaving as it should. It's a great tool for debugging. Hopefully we'll open source it someday, but we have some other burning issues before we do that. Okay. So, speaking as a platform guy, it's really, right, we talked about infrastructure as a service before, and so how do you overcome people saying, well, why do we need to change anything at all? It's working fine as it is. There's three things that you can do. First, you have to keep it simple. You have to build an app. You have to have your developers be able to build their app and not fidget around with the platform. If they have to start configuring things that are more than just a button or two, they won't adopt and use it. Show them the benefits, especially around pagers and on-call shifts. And time is the most valuable resource that we have in every R&D organization. So whenever you do changes and Kafka moves or upgrades or orchestrate any type of change, plan ahead, do it concretely, box calendar time ahead, and don't waste time. And I like to have our teams be envious of each other. Like if somebody says, whoa, that's shiny new Kafka clusters you have there, it really helps to bring along other R&D teams to adopt your infrastructure. So did we succeed? Did we have less pagers? Yes, we did. This is a graph showing our Kafka-related pagers week over week. Outside of work hours, because when we work, we unfortunately do a lot of self-noise, as it is. So you can see starting October, we really had a lot less nightly incursions of on-call shifts, and I was really happy about this. But what are those 10 remaining pagers? Of course, Bezos, thank you. Random Kafka hardware failures in AWS. It's always 3 in the morning. That's just our luck. But in any case, now we can sleep like a baby. Yeah. So, what's next? To handle those remaining hardware failures at night, there's a great tool called Dr. Kafka by Pinterest. It does auto-healing and moves the workload from the failed brokers to the working brokers. And if you have enough capacity, then it's a no-brainer. Hopefully, we'll POC it when I come back from this conference. AppsFlyer has now realized that the cloud is not endless. And we're moving into multi-cloud or multi-region architecture. So Replicator is a tool by Uber that does cross-data center replication. And we posted our benchmarks if anybody is interested in those for GitLab. We're also looking at Brooklyn that LinkedIn just published. It looks very promising, but it's yet to be seen if enough people will adopt it. Yeah. So Kafka 2 got released a few months ago. Kafka 2.4 is coming up on October 30th, I think. And there's a lot of interesting stuff there. But the two coolest features that they came up with in Kafka 2 are Z standard support. Z standard is a new compression mechanism by Facebook. It has comparable results to gzip, but uses much less CPU cycles. And when I read the documentation, they had a little asterisk there about Z standard for small data. And apparently you can train this compression algorithm on a small data set and optimize it. And on the POCs that we did, we fed it data from one of our topics, and then the compression was 10% better. So that's exciting. We actually want to create a topic registry with a dictionary, a Z standard dictionary for each topic, and really save a lot of CPU cycles basically across our production environment. We have 15,000 servers running on AWS at any given moment, so saving 10% of those would be great. And replica read, in Kafka 2.3, they released the consumer support for it. In 2.4, they'll release the broker side. It basically means that if your leader and follower are in sync and there are no under-replicated partitions, you can read locally. And for those of you running on AWS, you can read from the closest broker, and you don't have to pay the cross availability zones fees for networks. So that's going to save a lot of money for a lot of people. So I'm really excited about those two, and I'm pushing hard to move forward to 2.4. Remember, Kafka is king. Thank you very much. I really appreciate your input.
Does anyone have any questions? We have a few minutes.
I'm interested in your decision process to go with AWS, or is this Kafka running on AWS, or is it AWS
No,
Kafka?
it's vanilla, like Apache Kafka. We really try to be cloud agnostic as much as possible. We don't use any managed services as much as we can. We have a couple of RDSs, but we run Kafka on our own, vanilla. Confluent is constantly trying to get us to move to their platform, but it works really well, so there's no need, in our opinion, so far. And this work has been done by me and another guy for the past year. We just recently recruited a third guy, so you can do a lot of impactful things with a very small team if you have the right tools.
And the right people.
Yeah, that's a different kind of art.
Thanks for a great talk, by the way. And so I'm curious about the producer-owner model.
Yeah.
Do you have instances where you have more than one team producing into a cluster, and how do you resolve that?
Yeah. So everybody heard the question, right? So basically, we do have several incubator clusters for small teams or POCs or betas, where we'll have multiple teams producing to the same cluster. Those are usually really small teams, small scale, but when a product matures enough and has enough traffic where it starts to becoming, like I'd say that the minimum for a cluster would be, in our case, around 6 nodes. So anything that justifies 6 nodes would give that team a cluster. Well, we recently had, we do have a running beta right now that when I talked to the lead engineer there, he said, yeah, we expect to have 1 billion events a day when we launch into general availability. All right, that justifies the cluster on your own. You can't be on one of those incubating clusters. But yeah, of course, there's always space for shared clusters, especially for small debug topics and the small metadata stuff, not the core logic of the system.
Any more questions?
Did you have to spend much time tuning the the EBS volume or the particular configuration? Do you have anything to talk about that?
All right, so that's a really good question, actually. Almost all our Kafka clusters run on i3 instances. Those are SSD ones. We didn't really want to use EBS because when they fail, it really takes a long time to bring them back up. And when you're using SSD, it just 15 minutes, 20 minutes, and you're back up again. So that was a choice we made. We pay a premium on it. There are other instance types that are viable, like D2, if you know those. They have really big hard drives. But those, again, if they fail, bringing them back up takes a lot of time. And they become viable when your infrastructure is more flexible. Like if you can, this is a different talk completely, but if you have, right, when we talked, yeah, so when you talked about this, if we had a tool, for example, that we could say, all right, this cluster isn't functioning anymore, then we need to get out of it. We had a failure, and we could automatically have our consumers and producers move to that new cluster, then those instance types become viable. You just raise another cluster, and you let the broken cluster heal without any load, and you can take all the data that's important off of it into your backups, into your system, and then destroy it. But that's a different technological advance that I really hope we'll get to. We are seeing the building blocks for it here, like automation of all your provisioning and the topic registry, but it's like at least a year from now.
All right, please give a round. Oh, there's one more?
Yeah.
Maybe a quick one.
Have you looked into using something like Kubernetes to get a better utilization of resources for smaller clusters and also have the self-healing part?
All right, so Kubernetes, so Kubernetes, AppsFlyer doesn't use it right now. We are starting to do a POC, but it's really early stages. So the first, so for stateful infrastructure, it will be a long time before we do that. If you're interested in those models, then Datadog, actually, it's really funny because they set up a similar team to mine at the same time, and they decided to do all their Kafka infrastructure on Kubernetes, and they have amazing insights into that. So if you're interested in that, they have a couple of blogs about it, but I have no experience with it.
We are doing it as well, so that's also why it was trying to find somebody else.
Yeah, so Datadog are really, they're also a couple of guys, and they said Kubernetes is the way to go. And all their Kafka infrastructure is running on it, and they did an amazing job. I heard them talk like 6 months ago, so check out their blogs. They have interesting stuff.
All right, please give a round of applause to our speaker.